everyone. Thanks for coming to my talk. Come together right now over Mesh. It's my vague attempt at being on theme with Beatles puns. Vague of what I'm going to be talking about, but you'll probably figure out what I'm talking about as I go, so skip over that. So, who am I? I'm Vic. List of credentials there to try and make it sound like I know what I'm doing. Most important one's probably being a qualified falconer. So I'm interested in a bunch of weird things. Currently I'm very into weird protocols. Come chat to me about stuff. I'm so lonely with the pandemic. Please talk to me. So overview of the project and what I'm going to be talking about today. I've got going on this project looking at mesh networking with Raspberry Pis. And I've gone down several weird rabbit holes. I keep getting distracted. I keep finding holes in my knowledge. So this talk is going to be a bit of a brain dump, or I guess my stream of consciousness of what I've looked at, what it's led me to, where I'm going to be going in the future with my little research project. I apologise, it does go into the OSI model at some points, which I know some people have trauma around, so there's a warning. So first up, what's a mesh network? It's, well, with your home Wi-Fi, you normally connect your phones, laptops, etc. to a router. There's one central device that all of your traffic will go through. In a mesh network, you've got none of that. Any device can talk to any device. They can be configured in lots of different ways, like we've got this diagram here, where they're kind of chained together. So if you want to get to this node in the bottom right, you've got to go through the one next to it, which connects to the other ones. The exact configuration depends on what you're going to be using it for. You can get ones which are just for, you know, your home network. You've got various, like something that controls your lights, temperature, that sort of thing. Or you can get ones that are distributed over large geographic areas. It depends on what you're doing with it, really. Ad hoc mesh networks are the type I've been quite interested in, which are mesh networks which automatically reconfigure themselves. So if a node drops out of the mesh network, it will automatically just reconfigure itself, traffic can be routed around it, you don't have to worry if your node drops out. So what are they used for? There's pretty much any time you want data to be able to be transferred between nodes without it having to go through some central point. So something I've seen them used for is these explosive ordnance disposal robotics. That is me, I promise, in the picture. It's a bit low resolution, but yeah. So you've got the big robots, which are the ones that are actually doing the bomb disposal. And then you'll have smaller ones, which are just basically, you know, a camera with wheels. And they use mesh networking here, where the smaller ones can pass the messages along to reach the actual EOD robot at the end. Because you don't really want to worry about losing signal to your EOD robot at the crucial times. I've also seen them proposed for use in future connected and autonomous vehicles. So in the future, all of the, you know, cars on the roads, they're going to be very connected with each other. They're going to be sharing data with each other about their position, the direction they're heading, just various things, really. But you can't really connect cars to routers by the side of the road because cars go quite fast. So you'd have to be connecting to a router every, you know, 30 seconds or whatever. It's much simpler if the cars can all just communicate with each other and, you know, essentially transfer the messages by propagating them along roads through the mesh network of all the vehicles. So attacks on mesh networks. This is a bit of a cop-out slide because there's just so many. There's just so many different things you can do. It depends on what type of mesh network you've got, how it's configured, what protocol you're using to actually handle the routing. The vehicle mesh networks that I mentioned, they're likely to be susceptible to replay attacks. So in these proposed mesh networks for connected and autonomous vehicles, they've proposed that the vehicles will send out these heartbeat messages that are, hey, I'm an ambulance, I'm this big, I'm going here. I'm a car, I'm this big, I'm going here. So the road conditions will be changed depending upon what types of vehicles are on it. If you've got an ambulance approaching from one direction, traffic lights up ahead might be more likely to make that route green so that the ambulance can get through quicker. And the proposed protocols that they've been using for, or they want to use for these giant vehicle mesh networks, there's no actual unique value in them. There's no nonce value. So they're likely to be susceptible to replay attacks. So you could just, you know, record an I'm an ambulance message and play it as you're driving along, and then the traffic lights will change and be green for you. So it really depends on what exactly you're trying to do with the mesh network, what types of attacks it's likely to be susceptible to. Packet flooding attacks, those can be quite useful or interesting when you've got low-powered devices, which are only expecting to get a message every, couple of hours or so. if you're sending them constant messages, it might keep them in a state of wakefulness, so they'll burn through their battery much faster than they should do. You can also just mess with the contents of packets to cause weird routing issues between the nodes. You can force them to route through nodes which have actually got very poor connection strength or a high rate of data loss. You also get attacks with fancy names like Byzantine faults, which is where no node in the mesh network can actually tell where the issue is. It just knows there's an issue. So node A might think that node B is having connection issues and route around it, but node B thinks that node C is the issue, node C thinks that node D is the issue, etc. It's just because no node is actually obviously the one that's causing the issues, it's really hard to route around them. So building a simple mesh network. I've been playing around with Raspberry Pis at home because they're cheap and easy to work with. I've been using the Batman routing protocol. It was a fun name, and it turns out it's actually a really interesting protocol. I've been loosely following the guide there. People take photos of it if they want, but yeah, if you Google just Wi-Fi mesh Raspberry Pi, you'll find it. First up, we're going to talk about what is Batman. Batman. So Batman stands for Better Approach to Mobile Ad Hoc Networking. I'm never going to remember that, but it's for creating multi-hop ad hoc mesh networks. The mesh networks will automatically reconfigure themselves depending on what's in the network, what's in range. So if one of your nodes gets moved a bit further from the others and it's now, a higher latency connection, it will automatically reroute to avoid that node, that sort of thing. You can also connect your mesh network up to other things, like connect it to your home Wi-Fi, so you'll have like these bridge nodes which interact with whatever other network you're connected to, can go to the internet, you've got options. So a lot of mesh network routing protocols sit at layer 3 in the OSI model, whereas Batman sits at layer 2, so lower. And that's why we're going to have to look at the OSI model, just to give you a bit more of an understanding of what that actually means. So in the OSI model, I don't really care about 5, 6, and 7. They're too high up to really bother with. I'm more interested in 4 and below. So at level 4, you've got things like TCP and UDP. At 3, you've got IP. And at 2, you've got things like Ethernet. So because Batman sits at layer 2, it basically simulates the nodes actually being directly connected to each other. So the nodes see each other as linked local to each other. It makes the routing a lot easier and a lot more efficient. It does mean that when you're playing around with them, it's a bit more of a faff because you're kind of having to recreate what Ethernet would normally do. To give a bit of a better opportunity for explanation, I've stolen a graph off of someone which shows how data comes from the application, gets passed down, and ends up transferring. So you've probably heard of UDP and TCP. I don't know if I'm making assumptions. Don't ask me what they stand for, I can't remember. But the key difference really is in UDP, it's connectionless. You're just sending the data out. You're not getting any acknowledgement back on if it's been received or not. Whereas in TCP, it's connection-oriented, so you do know if your data's been received or not. So you get the classic joke around this of, I tell you a UDP joke, but I don't know if you'd get it. Terrible. So with the data that you're normally sending, it comes from the application. It goes down to the TCP layer, where it's divided up into little TCP segments. It's then passed down to the IP layer, where it's encapsulated in IP datagrams, which can then be sent on to whatever medium you're using to transmit your data. So Ethernet, Wi-Fi, whatever, it's going to get encapsulated there. And that's the layer at which Batman operates. So it'll be encapsulated there, sent across, then it goes back the other way, basically unpacking it all, and then it can pass it back up to the application. So yeah, going back to this, you can see we are dealing with layer 2, or Ethernet. It is a bit just my brain process of where I've been going during this project. And this doesn't look good on the projector at all, but this is just me running ifconfig on one of the nodes in my mesh network. So you've got your standard interfaces you'd normally see, like ETH0, your Ethernet interface. You've got, your loopback. You've got WLAN 0, which is wireless. At the top, you'll see BAT0, which is the virtual network interface that Batman protocol creates. So other actual legit, real network interfaces like ETH0, WLAN 0 can be assigned to BAT0, and then any data going through there in the using the Batman protocol will, it'll go through the bat0 interface, which simulates being linked local to each other. So the implications of doing it at layer 2, you can, within reason, use lots of other protocols that sit above it. You don't really have to worry about writing special software to transfer data in a Batman mesh network. You can just do it. It's fine. It's carried out in Linux by the Batman ADB kernel module. That actually makes it kind of more efficient because everything's being handled by the kernel. You don't have to read and write to user land on Linux. So it makes it a lot faster, which is quite good if you've got a mesh network where you actually care about the speed at which data gets transferred. In like the connected and autonomous vehicles example, there's been some proposals that you could have remote control vehicles in the roads. And to do that, they've said you'd probably need under 40 milliseconds latency. So potentially something like Batman could be suitable for getting that latency. I generally think that it's a bad idea to have remote control vehicles on the roads, but it's something that people have proposed. There are some pains with how Batman works. I think normal tools like ping and traceroute just don't work with it. It just tells you weird stuff. It goes a bit screwy. But they've got equivalents of them, like batctl ping, batctl traceroute, where it does the same functionality that you're used to, but works with Batman, so that's nice. So about Batman routing protocol features, it started as an improvement to optimize link state routing protocol, which is another mesh network routing protocol. It aims to decentralize the information about the nodes, so each node only knows how to reach the next best node. And this is done by each node sends out these little OGMs, which are little heartbeat messages. And any node that picks it up reflects it back to it. So you can say, okay, I sent this message at this time, I've received the reflection from that node at this time, I've got it back from that node at that time, well that node was faster, so I've probably got a better connection there. And these will get propagated throughout the network to a degree, where, node A will send its heartbeat that gets picked up by node B will replay it and it will get picked up by node C, and they can kind of, when that gets reflected back to node B will know that it was the one that sent that message to C, so it won't start repeating it again. But it will have that link information, which it will then embed when it sends a message out to, node A. So that basically each node knows the best kind of next hop within the mesh network. It can lead to some weird routing black holes, but there's some... Frankly, I don't have space to fit all the features they've put into Batman on here. There's so much complex stuff going on in it to try and create the best routing decisions that you can. It does a lot of stuff where it penalizes multi-hop connections because it wants them to be shorter just to increase the efficiency. It does a lot of fancy things to reduce the risk of interference. So it's designed to use, you can use Ethernet connections, Wi-Fi, whatever. They've tried to make it so that you can have Wi-Fi devices or wireless devices that can use multiple frequencies. So you might have one device that can communicate on 2.4 gigahertz, 2.4 gigahertz and 5 gigahertz. And you don't want to be sending and receiving on the same frequency because you might jam yourself. So Batman will automatically, if it's receiving on 2.4, it'll send it on 5. And then it'll kind of do that propagating forward. So if you've got the next node can only transmit on 2.4, can only transmit and receive on 2.4, the node before will try and receive on 5 so that you don't get actual accidental jamming. They do some very fancy stuff with this. A lot of effort has gone into this protocol. So this is the worst diagram in the whole slides. I have a touchscreen laptop and I like to finger paint with it. So here's my little mesh network. I'm using Raspbian Buster Lite, I believe, for the Raspberry Pis. I've just got them in a little daisy chain right now. I've got 2 connected on wireless, 2 connected on Ethernet. The one at the end, Raspberry Pi 3, can't use wireless right now, because that was kind of my way of guaranteeing that the traffic will be going through Raspberry Pi 2. Because if I had all 3 of them in just a wireless mesh, they'd probably just go directly to each other. So, I actually want them to be doing some routing stuff. I've also just got a router that I can plug directly into them to debug. But once they're all in the mesh network, I can do things like SSH from my laptop into the Bastion node, which is Raspberry Pi 1. And then from there, I can SSH into Raspberry Pi 2 or 3. Batman encapsulates and handles all of the SSH traffic, which is quite nice. Don't have to worry about getting into stuff too much. Top tip, that I've got thing on Linux called Terminator, which lets you just break down your terminal window into lots of smaller ones. You can split it vertically and horizontally, and it's been so nice on this project when I'm dealing with like 4 Raspberry Pis at once. I do have 5 in total, but I've only got 3 of them in the mesh right now. So here's some top tips of random commands that you might want to use when you're setting up a Batman network. In the top left, this is just some random networking stuff that I found useful. So in my setup, I've got the Bastion node, which it's plugged into a router that my laptop's plugged into so I can communicate with it directly. But that node can't actually reach the internet. And I'm dumb, and I forgot to patch things before setting everything up. So I was like, oh god, I need to get this on the internet. I don't want to pull the SD card and do stuff. So if you run those top 2 commands on, like your VM or whatever you can use to reach the internet, it tells it to forward any data it's receiving on the ETH0 interface. And if you then use the second 2 commands on your Raspberry Pi, it'll then let you just basically send all the data through your virtual machine so that it can get to the internet. And then you can update stuff and it makes life easier. Another top tip, explainshell.com, really good website. You give it a shell command and it breaks it down, it tells you what all the flags mean, it's really useful. Another one that's useful with Raspberry Pis is rfkill unblock Wi-Fi, because as default Wi-Fi is off on them. I got a bit confused with that one as to why it wasn't working before realising, oh yeah, I should read the disclaimer that it posts in the terminal when you start it up. Top right, we've got just some core Batman commands. So batctl ifadd wlan0, that's assigning the wireless interface wlan0 to bat0, so that interface can effectively be controlled by Batman. GW mode client is just gateway. It just means that it's a node that's part of a mesh network. They use a separate command to set up something that's designed to be the connection to another network. I've just kind of worked around it with my slightly janky network setup. Once we've also got like ifconfig wlan up to bring that interface up and bring the Batman interface up. I've written them in that order, but I recall having issues where if you assign stuff to the bat0 interface while, say wlan0, you want to assign it to the Batman interface. If you assign it while it's down and then bring the interface up, it goes screwy. Batman just does some very strange stuff and it doesn't tell you why. So top tip, bring bat0 up, bring wlan0 up, then assign wlan0 to bat0, or it'll do weird stuff. Also, stop DHCP. You don't want to assign an IP address to any of the interfaces, because again, it just does weird stuff. It just will not send traffic correctly, but it doesn't send any errors. There's no indication of what's going wrong. It just doesn't. Bottom left, network definition for creating wireless interfaces. If you're setting up a wireless mesh network with the Raspberry Pis, you just want to create a file at that location. I'm using Vim because I hate myself, and that's a list of what you'd want to put in that file. I've just got a little mesh network called VicNet. It's not very secure because I'm lazy, but that's what the that's basically the wireless network that things have been inducted into. Here, which you can't see because it's bad resolution, just batctlif tells you what interfaces have been assigned to Batman, and batctln tells you what neighbours you've got. Because you still, even though it's like using Batman, you're still contacting other nodes based on their IP address. So it's useful to just check batctln to see the IP address of your neighbours, because every time if you bring down and bring the mesh back up, it reassigns the IP addresses. So it's useful when you're trying to work out how do I reach that node. And we've got the batctl traceroute, which is just traceroute, but for Batman, it's a useful command, because if you're trying to verify that stuff is pathing through the middle node correctly, it's good to be able to see it. Status report. Where am I right now? Right now, I am in Scapy Hell. Scapy is a Python tool which lets you manually craft network traffic and mess around with packets. I've been spending way too long crafting packets and then looking at them on Wireshark and being like, why, God, is it doing this weirdly? So because Batman is at layer 2, it's basically, normally you'd have your Ethernet packet, and then inside that you've got your IP packet, and inside that you've got your TCP packet. In this, I'm replacing the Ethernet stuff. And Scapy doesn't know how to do Batman, so I've just been manually creating Ethernet frames and overwriting all the data in it. And sometimes that seems to work, sometimes it makes it go really screwy. Here's just a screenshot of one of the packets I attempted to make where Yeah, it's just added a bunch of Fs to the, I guess it's still on broadcast. I think that was when I was trying to send out packets using the wrong command on Scapy, and so it was actually encapsulating them with a malformed Ethernet frame. Another top tip if you're trying to get into networking stuff, just Wireshark's view is really nice. Like, it breaks it down by, Ethernet, IP, whatever, and you can click at the top, and it will highlight the bytes at the bottom, which are, relevant to that packet, or that aspect of the packet that you're looking at. So, generally, top tip, play with Wireshark, it's a cool tool. I click the button? Oh, where next? Right now I've just been recreating the heartbeat messages, which makes stuff upset a little bit to do. I need to actually start doing more targeted stuff. So either trying to simulate a malicious node that's sending out, stuff that it shouldn't be, or trying to intercept and manipulate any of the datagrams that are being sent around the network as part of its normal operation. The creators of the Batman protocol created a tool called the Joker, because, of course, you're going to call it that, which is designed for penetration testing Batman networks, and it can be used to send out things like packet storms to simulate a malicious node. It just lets you do a lot of interesting stuff, so I need to play around with that. I want to test out some of the hypothetical attacks on connected and autonomous vehicles. I've basically just got so many ideas of things I want to do with the mesh networks that I've not got round to it yet. I also want to have a little play around with attacks on the TCP/IP stack, I could do those on just a standard network, but it's much easier if I can guarantee the traffic's being forced through my system as it would be in a mesh network. So, seems like an easier way to do it. Thanks for watching. This has just been a bit of a brain dump of what I've been up to recently and where I'm going. If you want to read stuff, I've got the blog where it is just more of me rambling about stuff. I'm also on Twitter at Harkness, or I'm about here. If anyone wants to chat about mesh networks, come chat to me, or any just random shit. Also, I think I'm contractually obligated to say that F-Secure Consulting's recruiting, so come talk to me if you want to work at F-Secure Consulting. Yeah, thank you. If there's any questions? Yeah?
Have you done any speed testing with it?
Have I done any speed testing with it? I went down a rabbit hole, as I do on that, where you've got your normal ping command where it tells you the time. For some reason I missed that there was the batctl ping command, and so I started trying to recreate ping, but using it was done at TCP level. I was using Python sockets. And then I had issues with time synchronization, so then I went down a rabbit hole with NTP to make sure that the time was synchronizing on them, and that wasted way too much time, and then I got bored and realized that CTL ping existed, and then I lost track of that bit of the project. So no, I've not looked at speed tests, but it does seem to be quite fast. I need a bigger flat. I went through another stage where I was wrapping all of the Raspberry Pis in tin foil to try and give the signal strength a bit, and it was bad. My flat looked like it was full of bombs because there's all these wired things with tin foil, and it wasn't good. But maybe in the future I'll play around with that a bit more. Yeah.
If it accepted the wireless things, is that deal packs, deal between the two routers?
So can I do de-auth attacks between them? It's not something I've looked at because there's not really, with the Batman mesh network I've got set up right now, there's not any authentication. I've literally just got the VIC-net that's just there. There's no password. So I don't think nodes really say, I'm leaving, they just disappear. Or because all of the nodes are constantly reaching out and trying to see what they get a response from, then that's how they work out the mesh. So something that I want to play around with is, because these nodes are sending out the messages they've received, could I selectively target one of the nodes? So, I don't know, node A is sending to node B is sending to node C. If I could control node B, could I make it drop all of the packets coming from node A, but pass on every other packet that it receives from every other node? Because in that scenario, all the other nodes would think it's fine. And, if you had, say, you required 95% packet, of packet not loss, I don't know what that's called. 5% packet loss is acceptable. Anything above that is bad. If I could target that 5% on one node, that would be an interesting attack to play with. That one's not really a Batman-specific one. I guess that one's almost more of a TCP kind of stuff. I think in TCP there are various provisions for doing reliability of data transfers. But yeah, doing targeted packet dropping to make something effectively be left out of the mesh network is something that's on the lengthy to-do list of things to try. Hello. So Joker is designed just for the Batman protocol. So, you can use it to... It's a penetration testing tool, but it's a hammer. It spams out a bunch of traffic, which will make your network freak out. There's no kind of, fine-tuned, nuanced attacks. It's just designed to make a mess and make everything freak out. I guess that's why they called it the Joker. So it's just to upset mesh networks. I've not got round to playing with it yet, but it is on the to-do list of various things. Yeah. Any? Yep.
Sorry, can you centrally control this? Can you centrally configure it?
Nope. No, like in some routing protocols they'll each have like a little table of routes, which, I guess as I am in traditional ones, which gets propagated throughout them, but in Batman, no, it just goes, these are my neighbours, I know I've got this metric of connection to it, I know I've got this metric of connection to that one, I'm just going to send it to that one then.
Because it's designed to self-configure or something.
Yeah.
So that means it could be quite easy to choose a root device.
Oh yeah, absolutely. So that's one of the goals of this project is if I did just plug another device into it and assign, because if it is just a random mesh network, it's not very secure, I can just connect to it and I've added my node and I start sending out malicious stuff, what can I do? If I could somehow, become a better choice than another node and then have all the data be routed through my malicious node, I can then start doing the selective packet dropping or just, do whatever really. It's all about, malicious compliance, I think, for Batman attacks. You want to not be penalised by the network for overtly misbehaving, but you still want to be able to do nasty stuff to other nodes. Anyone else? Yep. There's so many different things that it uses. Yeah, so it's got like this link strength where it looks at the amount of time it takes for the next node to reflect it. But in the reflected packet, the node will also contain data about my connection strength to the next node is also this. And if you've got it'll also give an indication. I think there's just this one value they use for a lot of it that's controlled by a lot of things. So if you've got a node that's a couple out, it'll then reduce the value associated with that node every time it hops. Because sometimes I think you end up with scenarios where it's preferable to hop A, B, C than to just go A to C for whatever reason. Honestly, they've written so much on their website of all of the weird different things that they do to make sure that it's making the best routing decisions. Some of which are designed to try and avoid things like routing black holes, because I think that's something they had issues with in previous versions. Yeah.
I don't know if it's been mentioned, but have they had any issues with trademarks?
I don't think so.
I'm quite surprised, to be honest. Usually,
yeah, so far as I know, they've not had any, but I'm pretty sure it's a backronym rather than an acronym. But I guess because it's just a random Linux project, no one probably. Yeah, there's no money to get out of it. Anyone else? Cool. Thanks for your time.